moving about 175,000 tons of material per day. Of that, 35,000 tons per day of ore is delivered to the primary crusher and then processed in the concentrator. The 240-ton capacity haul trucks will dump ore directly into the new 60-inch primary crusher. The ore is crushed to about 6 inches in diameter and is conveyed by a 1 kilometer-long continuous overland conveyor to the coarse ore stockpile located behind the concentrator building.
You can see the fresh and reclaimed water tanks. We reclaim our water from the tailing pond, and our fresh water is secured from the Similkameen River. 61 megawatt BC Hydro substation.
Everything inside the concentrator building is controlled by a state-of-the-art electronic system that allows the operator to monitor the whole milling process. From the central control room, the operator can see everything that's going on in the process, from crushing the ore to the final product. From the coarse ore stockpile, the ore is conveyed into the concentrator building and enters the 34-foot diameter SAG mill that is powered by two 8,500 horsepower motors. In the SAG mill, water is added with the ore and tumbled with 5-inch diameter steel balls to grind the rock to less than 2 inches in size. This product flows to a 12 by 28-foot vibrating screen that allows the ore that is less than a ½ inch in size to drop through the screen and be pumped to the 2 ball mills for further grinding. Ore that is greater than ½ inch travels across the screen and is conveyed to a pebble crusher, where it is crushed to approximately ½ inch in size and returned to the SAG mill for further processing. The two 24 by 40-foot ball mills, powered by four 8,500 horsepower motors, use 3.5-inch steel balls to grind the ore finer. The ball mill product is then pumped to cyclones, which separate the coarse material from the fine ore, with the coarse material reporting back to the ball mill. The water and fine ore, which is ground to about the size of salt mixture, flows to the rougher flotation circuit. The separation of the barren rock from the copper minerals is performed in the rougher flotation cells. Flotation cells have impellers that mix the ore and water mixture. Bubbles are created by adding air and small amounts of alcohol to the cells, and the copper minerals are coated with a collector that allows the copper minerals to stick to the bubbles in the flotation circuit and float to the surface. The mineral concentrate from the rougher flotation circuit contain about 5% copper. This concentrate is further treated in the regrind mill and cleaner flotation columns to produce a cleaner copper concentrate containing approximately 25% copper. The cleaner flotation concentrate, which contains the copper mineral that has been ground to the consistency of talcum powder, flows to the thickener where the solids settle to provide a mixture containing 50% solids. This thickened concentrate is then pumped to the filter press panels, where the moisture content is reduced to approximately 9% moisture. The final concentrate consists of copper minerals containing 25% copper and small amounts of gold and silver. At $4 copper, the copper concentrate is worth approximately $2,700 per ton. Copper Mountain is targeted to produce approximately 175,000 tons of concentrate per year. The final concentrate is trucked to the Port of Vancouver in 50-ton B-train units in preparation for shipping to Japan, where it will be refined and smelted into copper, gold, and silver metal.